Okay, so day 2 of 12.1 starts out by talks about properties of limits. It says here, given, now there's many properties and I didn't want to put them all down, so what I said to you was this. I said, see page 855 for more properties. And you will want to kind of read them just because then it gives you an idea, oh, I can just do that and get the limit. Yep, you can. But let's just go over a couple of easy ones. Here's a property right here. This one says, if your function happens to equal a number like 2. Well, that, you have to understand, that is a graph. That really says y equals 2. What does y equal 2 look like as a graph?
A horizontal line.
Yeah? Is it horizontal? Yeah. Okay, good. It is. 1, 2. So, Davidson, you are correct. Okay, what's the limit of this function as x approaches what? 5. As x approaches 5, what's the limit? Well, here's 5. So if you try 7, 6, 5, I mean, you're going to get that answer, that answer. Every time you get this answer, what's the answer? 2, 2. So you're moving in towards this point, and the answer right there is 2. But now if you come in from the left side, you get this answer, this answer. So once again, you're converging right there. You're still going towards that number. That number is 2. So what's the limit of your function if your function is just a number?
The number.
The number. I know what you're saying is 2. I get it. So here the limit is what? 2. But in your notes, in your properties, if you went and read the property, here's what the property looks like. What is, sorry. What's the limit of b, okay, and b is a constant number like 2, 4, 6, 8, if x approaches c. What is the limit? Now b is a constant number like 2, so it's b. If this said 3, you would have told me the limit is 3. If this said 7, you say the limit is 7. Well, if it's b, you just say the limit is b. That's one of the properties. And then you read the next property. It's this one. If g of x equals this, which means y equals x, what does that graph look like? 45-degree line, or a line with a slope of 1. So here's a line with a slope of 1. Here, right? Okay, or it continues this way. What's the limit of g of x, this function, as x approaches 5? Okay, you say 5, I heard you. Okay, so up here is the point. If you kept trying numbers from the right, you just get these. And you'd be moving in towards that point. From the left, you'd be moving in towards that point. What's that point over here? It is 5. Because if you tried 4, you'd get what? 4. 3, you'd get 3. But more or less, if you get just x, simply x, then the answer is, what's the limit of this? What's the limit of this function x when x approaches c? C. Do you agree at c?
Yeah.
Okay, because when I approached 5, the answer was 5. If I approach 4, it's 4. So you're right, it's C. Now, this is just 2 of the 8 or 9 properties. If you get into it, guys, you'll just read them, you'll go, oh, yeah, that makes sense, Oh, I can, and then you go, I can do all this? Yep, and you can do it quick, and the answer comes out quick, yeah.
Is your limit, is that your y value?
It is y, it's the answer, and the answer is always y. Because we're approaching the x value 5. What's the y value? Well, in this case, it's 5. And like you said, can't I just put that number in? Put 5 in for x, you get 5. Yeah. Okay. Now, okay, here we go. I think I kind of answered this question. I think I did. Can you find these limits without a graph? Wait a minute. Is this the right slide?
Yeah.
Oh, okay. I don't think I did this one last hour.
Why does he do that?
Can you find these limits without a graphical or numerical approach? What? 2x minus, yeah, what's the graph for? That's a good question. 2x minus 5, it is right here. But that is the graph, but can you do it without the graph?
Yeah.
How?
You just plug in what it approaches into the equation.
Why can you do it? Why can you
Because
just
it's
do it?
Because it's a line.
It's continuous graph.
It's
There's
not.
no breaks. So go ahead, do this. 2 times 3, take away 5. 6, take away 5. The answer is what?
1.
So the limit is supposed to be 1, right? Okay, is it?
Yes.
Just check it out. Here's 1, here's 2, here's 3. So if I looked at that graph and I came in from the right side, I'm just getting this. So I'm getting all these answers, and I'm approaching this point. From the left, I'm approaching that same point. That's what? It is 1. It works. So tell me the easiest way to find a limit.
Look at it.
Plug it in, that's it. That's it. Okay. Is this continuous? What is this?
Parabola.
It's a parabola, it's continuous. If you want the limit, sorry I didn't write that. If you want the limit as x approaches 1, go ahead, plug it in. What's it going to be? 1 squared minus 3 times 1 plus 2 is? Is it 0? 1 take away 3 plus 2 is 0. The limit is 0. Okay. Good. So plugging it in seems really easy, doesn't it? Yeah. Does it always work? No. But here's the last slide, how to find a limit if a limit exists. Okay? So when you get the test, please do this. Number 1. Always do number 1. And it does say algebraically. So it says substitute the c value into the function. This is known as direct substitution. If you get a real number, you found the limit. That's how easy it is, right? So what's the limit of 6x minus 2 when x approaches 5?
28.
28, because you just did this, right? 6 times 5, take away 2 is 30, take away 2, 28 is the limit. Those are nice. Yeah, I made it easy, but that's how easy it is. Okay. B, if you get an undefined result, so if you plug this number in, you go, oh, I get any number over 0, so 6 over 0, 10 over 0. What does that mean? The limit, what? Does not exist. Why? Yeah, you basically ran into a asymptote. You ran into a vertical asymptote, and what happened was the graph went this way up, and then on the other side it went this way down, and you're not approaching the same number. Okay? Good? So this is kind of nice. You like this. Any number over 0, you just say what?
That doesn't exist.
Yeah.
D&E?
That's the good one. Now here comes the bad one. The bad one's right here. Number 3. If you plug your number in, and if you get the indeterminate form, 0 over 0, you get 0 over 0, then more work is required. There could be a limit. And it says the limit does exist, but there's a hole at C. And sometimes the hole at C means there is a limit, and sometimes we might not get one. But how do we get that? How do we explore it and get it?
Well, there was one yesterday where there's a parabola and there's that hole. So it still approaches that point,
Yep.
but the point doesn't.
Yep. So you're saying there was one like this? Like that?
Yep.
Yep. And then you said at 3, the answer was really up here.
Yep.
And as you approach it from the left, from the right and the left, it looks like to me that's the limit. Let's call it 5.
3.
Okay. But some students will go look up here and they'll go, no, the limit is 10. And really it's the number you're approaching. You're approaching this point, which is 5 is the limit. This is actually the answer to your function if you plug what in. If you actually plug the number 3 into your function, you go up, you hit this point, you say, that's not the answer, keep going. Oh, the answer's 10. But the limit is what? The limit is 5. That's the trickiest problem I have for you. I mean, some students are going to say 5's the answer. Some are going to say 10's the answer. It's what you're approaching. You're approaching 5. The real answer, though, if you plug it in, plug 3 in, you get 10. Okay, but nobody said it. What's the way we're going to try to get this answer? More work is required. Here's what you're going to do. You're going to do this. Make a what? Or you're going to graph it. You can do it with your calculator. You can do it by hand yourself. The table, I recommend, use your calculator. The graphing calculator, because it's really easy. I'm done.
We got a question.
Yeah, go ahead.
Why do you use backgrounds?
Yeah, why do you use colored backgrounds on your slides? Because sometimes it makes it
Harder for you to
black
see?
and white.
Mm.
It makes it difficult to.
It's more for your visual.
You alternate too, because you go like all white sides and then a pink one.
Yeah.
Or
Well,
like a dark blue